Welcome to the Blend Bridge tutorial number 1. I start out with a list of the application. To obtain Blend Bridge, just Google it. Task to be accomplished in the tutorial. Hinge nomenclature. Here's the STL file from the Elmer GUI directory and gratefully acknowledged. I'm using points of the model itself to give me a right angle for cutting it. I modify an edge and use it as a cutter with the knife project command. Once the cut is made, I delete the cutting edge. I give the command to convert triangles to quads, but it isn't too effective. Cutting the model in half horizontally is the next step, and it is done in the same way using an edge as blade. I'll do some geometry cleanup on the guide. I simplify the model by deleting the lower edges of the leaf and guide. Many of the top surface edges need to be dissolved. Here's a likely edge. I remove the knuckle and guide sections and store them out of the way on a different layer. The hole divisions are too detailed. I need to do some reduction. Most of the simplification I will do off screen. In this case, making faces is mainly a matter of connecting the holes with the outside boundary and with each other. Meanwhile, avoiding triangles and pentagons. I want my vertical dividing line to go through the point separating the guide from the knuckle. So I need to go get that X value and copy it, and then paste it into the ends of my edge. The refining process for angles is abbreviated here. I will polish a little more off screen. The first extrusion will be of the top surface, which in this case is complicated by hole bevels. I might as well roll them into the same operation. The vertical divisions of the guide dictate the vertical structure, so I need to determine the numerical values of those levels. The excellent capture utility Snappy makes a picture of the 6 edge lengths for reference, but it is invisible here. The edges are extruded and the hole bevels hang down too much. I need to make the bevel bottoms the same height as the neighboring edges. I put horizontal faces on the bottom using a face filling command, but it is not thorough. I will finish with the cleanup off screen. The standard routine for creating regular mesh is to first extrude the edges parallel to the extrusion direction, then fill in the faces perpendicular to the extrusion direction, and then remove the doubles. Here I select the lowest existing set of horizontal faces and use them for duplicating and distributing. I need to know the x-axis lengths of the edges so I can build the guide and the knuckle. Again, Snappy takes the picture. The slimmest edge outline of the guide is all I need. This repeats the earlier process with the leaf, only now the extrusion is horizontal. The lowest level of the guide has some marginal angles suspiciously high and low. A quality check needs to be done to assess the situation. I need to place the exported file in a place that Gmesh will be able to access it without difficulty. The small file whizzes through BlendBridge in a moment. In Gmesh, I check the mesh option settings and then create the mesh with a click of the 3D button. In ParaView, I look at the scale Jacobian quality of the guide. Somehow it turns out to be quite good. Creating the pattern of end faces on the knuckle is not difficult. No awkward angles are there to challenge me. For extrusion distances, I am referring to the edge lengths of the leaf faces, which I recorded earlier. To join the sub-assemblies, I first put everything on the same layer. One is already selected, so I only have to select the other two. Everything looks good here, but the seams where the parts were joined are often a problem. To remove doubles, press a remove doubles command and it removes 42 doubles. When sounding the points, more than one click on a point is often required to see if it is spongy. If it is, the required action is to merge a small circle around the points. For the first sheet of points, I will take care of most of them off screen. The curve sheet is interesting. It contains exactly 42 points, the number of doubles that were removed after the join. I believe this explains why all the points on this sheet are sound. Sometimes mirroring can be tricky, but in this case it goes smoothly. "63 doubles are removed, which is the same as the number of points on the cross-section of the mirrored seam. This section is less chronological than a montage of software connections. The main thing is that the final quality is good. That's it. Thanks for watching.